Hello, everyone. So, welcome to the 14th meetup of the AWS Geneva User Group. If you don't know me, I'm Mohammed Bouchnafa, and I'm an AWS community builder and the organizer of the AWS Geneva User Group. So just a question, everyone hearing me? Just comment if there is any problem. Yeah, very good. Cool. Welcome, Elena. Welcome, Boot00. So today we will welcome Nick Jones. I will give him the spot just after, but I have a quick introduction to tell. So like I said, we will welcome Nick Jones today. He's one of my fellows in the AWS Community Builder program. He's from London, and he will talk about security at scale for AWS workloads. But before introducing Nick and let him perform, I wanted to tell that after his talk, we will have our traditional quiz. So to play, you will have to get a PIN code by sending a direct message to our quiz bot on Slack. So you'll have to join Slack. There is the QR code on screen, and I will send the URL just afterwards. Ask the quiz code on DM. Just send play and follow the instructions. It's very easy. Just give your nickname. The idea is just to know who is playing, identify then the winner, and we can afterwards send him the gift. Maybe you've seen during the introduction the different videos, the small video. The big information here is that we'll have the AWS Summit in June. So I will also give the URL in the chat just afterward. I'm finished. We'll see afterward how the quiz will go. But for now, let's talk with Nick Jones. Just one moment. I will add him to the stream. Hi, Nick.
Hi, everyone. Can you all hear me okay?
I'm hearing you okay. I think everyone is hearing you okay also.
Fantastic. In which case, then, I think we're good to go.
Yeah. Let's
Brilliant.
go.
I'll crack on. So hopefully you can all see the slides again. Shout if not. But we're here today to talk about securing your AWS workloads at scale. And what I mean by that is doing effective security, especially in organizations where there is a lot of cloud going on rather than just one or two projects, as that's often where some of the best practices and things start to fall down in my experience. They get harder as you scale. So we'll talk about some of that as well. This presentation is going to cover what your cloud security landscape actually looks like. There's some misconceptions around this, or people often don't necessarily think about this in the right way. So we'll dig into that a little bit first. Next up, how's an attacker really going to target your workloads? You know, there's a lot of noise being made by various people about how attackers do things, what they're going to do to you. This is based off my experience, and so we'll get into that in a little bit as to why I've got at least some authority to be talking on it. And lastly, what are the key controls to have in place? What are the important things to get right in your cloud environments? And then some guidance on scaling a lot of that out across a larger organization, as I say, that hopefully will prove useful to at least some of you. So, who am I? So I'm Nick Jones. I'm a senior security consultant at F-Secure Consulting, where I lead our cloud security team. AWS is my personal specialty there. I'm part of the Community Builder program as well. It's how I ended up doing this today. I developed LEONIDAS. Talk a little bit about that at the end, but it's an attack simulation tool for the cloud. There's a bunch of previous conference talks out there from me, mostly about attack detection in the cloud, but on a few other things too. So first off, your cloud security landscape. What I want to do here really is take the opportunity to help everyone understand what your landscape actually looks like, what you have to consider when you're modeling the security of your cloud environment, when you're trying to understand it. And there's perhaps more to it, I think, than most people initially anticipate. So this is a very simplified model, but often when people think about AWS security, really they're thinking about perhaps a number of different workloads across a few different accounts. You've got an AWS organization. You might have some continuous integration and deployment tooling, either in AWS with the CodeStar services or as part of some other platform somewhere, maybe Circle CI, or you've got Jenkins or something. And that's about as far as people usually think. In many cases, actually, people don't always think about the source code and the continuous delivery piece either, but we'll get into that in a bit. The real challenge comes from the fact that this is rarely the entire scope. People do threat modeling for their individual workloads. They'll do some security testing on the organization as a whole, service control policies, these kinds of things. But there are quite a few other things that tend to impact your security. So it's rare I find a medium to large size organization who is purely in one cloud provider. Often you'll start talking to the cloud engineering teams or whoever it is that's responsible for their cloud usage, and they'll say, oh, we do AWS, or we're in Azure shop. And then some engineer at the back will stick his hand up and go, oh, well, actually, there's this workload over here that's in Google Cloud because their Kubernetes clusters are better. That's the usual culprit. But it's really common to see multiple cloud providers. So you've got that complexity. Source code's often being hosted by GitHub or managed GitLab or something, some other service that's outside of your direct control. You're probably pulling your Docker images in from Docker Hub. So the provenance of those and how secure they are is open to question. Your documents are probably in either Office 365 or Google Workspaces or something like that. You've probably got Slack. Or if you're unlucky, maybe you've got Teams instead. My condolences if so. We've got a number of these SaaS products all working together as well. And from an attacker's perspective, that whole box, your endpoints that your developers are using and the rest of the business for that matter, your main cloud workloads running in AWS or wherever else, and all of these SaaS products are all things that an attacker is going to target. And a lot of these supporting services often get left out or get forgotten about or get looked at once when they're first built, but perhaps aren't regularly revisited to make sure that the security posture stays up to date as things evolve and change. And so this is obviously a lot to think about. And realistically, most organizations don't think about all of it because it is too much to think about, or because they don't have a complete view as to what all of it looks like, because one engineering team over here has just found their credit card and gone and bought something, So that's a real challenge. And one of the key things really is actually prioritizing what really matters. Security budgets are usually quite small, especially in smaller organizations. There may not even be a security team, right? It might just be a few engineers who've got an interest in it, who've picked it up as part of their responsibilities, at which point prioritizing where you put your time becomes really, really important. And so hopefully what I'll do across the rest of this presentation is help you understand, where best to put that limited time and value. And so to do that, we're going to talk about how attackers operate in the cloud. What's an attacker actually likely to do, and how are they going to do it? But first up, I wanted to dispel a few kind of common myths or misconceptions that I often hear when people talk about security or cloud security in particular. This is mostly my opinion. I hold some quite strong opinions on things, but this is borne out by experience and real world examples. The key thing really is attackers will always look for the path of least resistance. So the easiest way to compromise you is going to be what an attacker does. In many cases, attackers aren't targeting you specifically. They're on a mass campaign to find as many opportunities to mine Bitcoin or Monero or something, or to ransomware whoever they can or whatever else. And you happen to be one of the organizations that came up on their radar that they went after. The basics for your security that stop those kinds of opportunistic attacks are often also extremely useful when it comes to stopping APTs, as the security industry like to call them, nation-state threat actors, high-end cybercrime gangs, the kind of things that keep most security professionals up at night. Getting the basics right does an awful lot to slow them down as well. And the SolarWinds breach that I'm sure everyone saw sort of late 2020 was a great example there, in that what unraveled the attack was an employee at FireEye saying, no, actually, I didn't ask for that two-factor authentication prompt. and FireEye's security people going, oh, okay, well, let's have a look at who did ask for it then. And it unraveled an enormous Russian-backed state actor that had breached a whole load of US government networks, purely because they'd got the basics right. They had that two-factor authentication in place, and someone was investigating the alerts that were coming out of it. And so when it comes to the cloud, most organizations get breached by forgetting the basics, right? Larger organizations often have a lot of cloud accounts, and not all of those will have been brought under the centralized management systems, or they won't all be monitored by your cloud security posture management tool, or whatever other buzzwords Gartner have come up with this week for your security monitoring. That's what happened to Capital One. They had a legacy account that they didn't have onboarded into all their nice new security tools, and so things got missed. S3 buckets with public access, we'll get onto that in a bit, but I don't see that one going away anytime soon, unfortunately. Leaked credentials, so either people reusing credentials between services and there being a breach, or credentials being posted to GitHub by accident. And lastly, people giving very high levels of privileges to things that don't need it because there was an engineering deadline and this thing had to get made to work. And so someone said, all right, just give it full access to everything. We know that works and we'll come back and fix it later. Spoiler alert, no one ever comes back to fix it. Or it's very rare that people do anyway. There's no such thing as a temporary fix. Things tend to last for a surprisingly long time. And on top of that, then, things that you probably won't get breached by. And I'm going to say probably because inevitably, now that I've said this, it's going to happen to someone. But generally, how you've got your encryption at rest set up and using all the right custom KMS CMKs for your data and things certainly makes the auditors happy, but probably isn't going to stop a real attack. Equally, I remember going to an AWS meetup in Copenhagen in early 2020, back when we were still doing these in person, and there was a big discussion around Nitro enclaves and how it was going to be able to make people defend their estates better against advanced attacks and seal off their cryptographic material better and things. No realistic threat model was going to get stopped by that, or at least those that were, the attacker was going to find another way into the environment, because realistically, whoever it was that was planning on doing that very likely had IAM misconfigurations that were a bigger problem, or had some public S3 buckets somewhere, or something else. Equally, 0 days, which is the security industry term for those not familiar, for new vulnerabilities that someone discovers that weren't previously known. They're a problem, sure, but the chances of there being one in AWS that is then used to target your organization specifically is pretty low. And I can count the number of public 0 days that I know were exploited in AWS on one hand with fingers to spare since AWS was founded, right? They're generally pretty good at catching the really big stuff before it goes into production. And because of the nature of the cloud, how little access you have to go look at things, it's quite hard to find them too, compared to finding these vulnerabilities in, say, an iPhone or a Windows machine. Equally, you often hear people threat modeling disgruntled engineers at AWS, or an AWS staffer deciding to go rogue and break into your account. And again, something to consider, something to bear in mind. I'm not aware of any case where that's actually happened yet. AWS have some pretty robust audit controls in place and processes for who gets access to what. Even in the case of Capital One, where we thought that might have been the root cause, it was an ex-AWS employee who used the knowledge they gained there to do the attack, rather than them using their AWS access to perform it. It was purely because they got some cloud experience and that they worked out what to do. And I suspect a lot of the people in this meetup could probably have done the same. So now that we've talked a little bit about the kind of the common myths and ways you're not going to get attacked, what's an attacker really going to do? Initial access usually comes via a few routes. Public storage, your open S3 buckets, but that's not the only one. I'll get into that in a second. Application vulnerabilities, that was what happened to Capital One, and I'm sure there are other examples too. We'll talk about the most pressing concerns there in a second as well. Exposed credentials, either via GitHub or via people sharing passwords between accounts and a breach occurring. And lastly, sort of grayed out in the corner there is targeted attacks, where an attacker is specifically going after your organization. And the way they'll probably do that is with phishing. That hasn't really changed when it comes to the cloud. It's still easier to convince an end user to do something stupid or to get them to open an email they shouldn't than it is to breach most cloud environments, provided you've got the basics done right. You haven't got public S3 buckets and things. So, public storage. This is the rather depressing array of media headlines and things for this. Shodan, for those not familiar, is a tool that, or a website rather, with a backend that scans the internet looking for open things. And you can see there that they've found over 20,000 open Elasticsearch clusters, right? Of which 891 down the bottom there were hosted in AWS. So it's not just public buckets. You can expose Elasticsearch, managed Elasticsearch, that is, to the internet by accident. DynamoDB too. I'm sure there's plenty more. Those are the three big ones that I've run into personally. And this is just people not paying attention to what they're allowing out onto the internet, essentially. Used to happen plenty in on-premises networks. This isn't a new thing for the cloud, but it tends to be a bigger problem because, if an S3 bucket's public, it really is out on the internet, whereas it's generally harder to find public stuff, or at least you've got to go looking for it more with on-premises networks. So step one of all your cloud security programs should definitely be make sure you haven't got S3 buckets, DynamoDB, Elasticsearch, things like that, exposed out on the internet full of stuff you care about. Next up, web application vulnerabilities. I bring this one up because, probably the cause of the most high-profile AWS breach so far. And it's something that we've done a fair few times on security engagements where I've gone along to test the security at a client. And so what happens here is, for those of you who aren't familiar, you have the EC2 instance metadata service, which is a web endpoint that's exposed to an EC2 instance that provides a lot of information about what the EC2 instance is, the hardware it's running on, all of these kinds of things. But it also exposes the credentials that the instance role uses to then talk to S3 or RDS or any other AWS service that it communicates with. So what happens is an attacker can request something through the web app, exploit some kind of vulnerability, and through that find themselves with access to the system or the ability to make requests through the system. We then reach out to the instance metadata service. We say, give me the contents of this URL, which brings back some keys. They look just like what you're used to seeing when you're working on the command line. Those are temporary keys. They're usually valid for an hour or two, I think, from memory. And an attacker can then, actually, this is a slight simplification on the diagram here, but you can then use those keys from anywhere, actually, once you've got them, to go access these files in this S3 bucket, at which point we give them back out to the end user, to the attacker. So what we can do as an attacker is make a request through the application, if you have server-side request forgery is the vulnerability name, to steal those credentials, go get some stuff out of an S3 bucket, or interact with other AWS services with those credentials. And it's not a good thing. So this is exactly what happened to Capital One. They had an application vulnerability that allowed an attacker to do this. So AWS brought out Instance Metadata Service version 2, which requires that you submit an additional HTTP header to the Instance Metadata Service in order to access anything useful. And that breaks a lot of common server-side request forgery vulnerabilities. And so is a really useful extra hardening step that you can take to make an attacker's life harder. By default, it's only Instance Metadata Service version 1. You have to explicitly go in and turn off version 1 and enable version 2 in the configuration for your EC2 instances. And that's because it breaks backwards compatibility with a lot of things people might have built historically. So AWS don't enforce it by default, unfortunately. It's on you to go away and make that change. So I would definitely recommend as step 2, once you've gone through and made sure your S3 buckets are private, take a look at your EC2 instances and make sure this is turned on. Now, what also happens, here we're talking about just talking to an S3 bucket originally, but it's often used as a foothold to get further into the account. You'll have to excuse the Azure diagrams. I know they're a bit off brand, but essentially If you're then also talking to things like Kubernetes clusters, if you've got your applications in there, that initial foothold that an attacker gets might be enough for them to start talking to the Kubernetes clusters APIs. Maybe you actually talk out to AWS Secrets Manager, you start stealing secrets and use them to pivot elsewhere into the environment. That initial foothold isn't usually where an attacker stops, but it's a key first thing they have to do. So the more you can do to make it harder for them, the better. Now, I said targeted attacks earlier. There's three key things really here to consider. The first of which is identity management. Now, when I say identity management attacks, what I'm talking about is attackers leveraging credentials that they've got in one way or another to gain access to your cloud environments. And there's a big breach report published every year by Verizon's incident response team, and they reckon that for 2020, something like 70% of the cloud incidents that they responded to involved compromised credentials or access keys or something like that. And the two most common ways we see this happen is either an attacker stealing credentials out of a source code repository on GitHub. It's surprisingly often that you see people accidentally committing keys to public GitHub repos, or they've stolen some credentials from somewhere else and they log in via your single sign-on and start attacking your infrastructure from there. Now, in the case of access keys hitting GitHub, the mean time to compromise, so the time between them arriving on GitHub and an attacker doing something bad with them, is now down to under 30 seconds. Because as much as we've started doing continuous delivery for building our applications and deploying them, attackers now have their own CI/CD pipelines that they feed these keys they find into that instantly deploy Bitcoin mining rigs usually, or Monero or some other cryptocurrency into the compromised AWS account. It's gotten bad enough actually that AWS themselves have started monitoring the GitHub public feed of new commits and scanning those for access keys so that they can revoke them before an attacker starts Bitcoin mining. So that's less common than it used to be now that AWS have started doing it, but it's definitely still a concern. So keeping an eye on the contents of your GitHub repositories is definitely a useful one there. So bilateral movement, what I mean here is cases where an attacker started with a foothold in one place and they've moved to another. So the obvious one here is an attacker who's phished an end user. They've got some malware on their device, or they've used it to steal some users' credentials, and they've then used that to move their way up into the cloud. This is really common in larger enterprises where everything's based on Active Directory, and people use some kind of single sign-on to move into AWS. Or to do things in AWS with their Active Directory credentials. And so an attacker can steal those Active Directory credentials and then log into AWS with them via the single sign-on. This is something that you don't see in the news as much, I suspect, because people aren't looking for it. I suspect we'll hear much more about this over the next sort of 12, 18 months, because this happened in the SolarWinds breach to a degree. And it's something that we've been exploiting on red teams and penetration tests for some time now. And often we find that as the more basic security vulnerabilities start being fixed, attackers move more towards fancier stuff like this that we've perhaps been exploiting on penetration tests and red team for a while. So I'm expecting that this will be more prevalent coming in the coming years and months. Lastly, source code management and continuous delivery, right? So this is an attacker who's got some kind of foothold inside your network, and they can talk to your code repositories or your CI/CD system and make some kind of changes. Maybe only as a developer, they might not have admin access over it. But if you're using infrastructure as code, as I hope most of you are, and that's being deployed through a CI/CD pipeline, if the attacker can change the code as it is living in the repository, or they can change what's happening in the pipeline, then they effectively can change what's running in production in your systems, right? Because either the pipeline deploys this altered code that's now in your code repository, or the pipeline can be changed by the attacker to modify the code as it goes out into the cloud. So this is often an area that we find people either forget about or don't see as much of a priority as the production workloads running in the cloud. But from an attacker's perspective, being able to get into your code repositories or your CI/CD pipelines is, that's about as good as it gets, because you tend to be able to take control of an awful lot of things from there, and they're not generally as well secured or as well monitored as the production environments themselves. So once an attacker's got some kind of foothold and they've broken in, how do they stick around? There's the old mechanisms that we're used to working with on premises that I'm sure you've probably heard about over the years of someone sending you a virus or some kind of malware and using that to do something on your computer, come back later, perhaps log back in again. That still applies to some degree, especially when we're talking about developer workstations that they use to manage your cloud estates. But there's then also like a new range of persistence mechanisms, ways that attackers can stick around that come with moving to the cloud. So the most common one that we end up using on security assessments is adding new access keys to IAM users if they're there, or equally adding logging profiles or changing users' passwords to get into the web console. That is obviously less useful in environments where IAM users don't exist. In many environments now, everyone's moved on to single sign-on and using IAM roles for everything, which is great. Definitely recommend doing that, but it means that we then don't have that as an option there. Equally, adding SSH keys to servers running, that kind of thing, less prevalent, but still does happen. So some things to watch for in your logs. People adding new access keys where they shouldn't be, people creating login profiles, people creating new IAM users, in fact, in general, is quite obvious in many environments. So definitely keep an eye out for those. Now, key security controls. First up, identity controls. We talked about how attackers like stealing credentials and using those to break into your accounts. One of the biggest defenses against that is multi-factor authentication. So enforce that everywhere. If you've got a single sign-on platform that people use to access your cloud workloads, then make people use multi-factor authentication to get in. Likewise, you can configure various AWS policies or the policies on your AWS roles to require people to log in with multi-factor auth. There's a is multi-factor auth present IAM condition that you can use to do that. I generally recommend avoiding SMS-based two-factor auth where possible. Apps like Google Authenticator, these sort of time-based 2FA apps are fine. If you can use YubiKeys or some other kind of hardware thing, then great, they're even better. But sort of the app-based ones is what I consider a bare minimum there these days. Principle of least privilege is sort of the rallying cry of many security people. And it's easier said than done, but it is worth putting the effort into, making sure that your IAM roles and the policies you attach to them really do have the fewest privilege possible to do what they need to do, both in terms of the actions that they've got the rights to do and the resources they can do them to. There's two tools out there for doing that are quite useful to help you understand your current IAM configuration and then find things to improve. The first of which is Cloudsplaining by Salesforce. Kenneth McCabe built that one, and that's a fantastic tool to have a look at, very easy to understand. And then for deeper dives, one of my colleagues built a tool called Auspex that you'll also find on GitHub that allows you to do graph-based modeling of your IAM configurations and say, okay, given this S3 bucket, who can do things with it? Or who has the rights to assume this role or things like that, can really help you get a better understanding of your IAM controls than just looking at the JSON until your eyes bleed, which is what we used to have to do before people built tools for it. Next up, and do your best to reduce or eliminate long-lived credentials. IAM users in particular, like access keys that hang around forever, is not a good thing for anyone. And so you can do things like use IAM roles on instances, instance roles in EC2, instead of having IAM users with their access keys lying around. Well worth investing some time in that if you've got a lot of IAM users at the moment. Same thing for SSH keys, right? You can also do certificate authority-based SSH authentication and sign certificates for short periods of time so that production access doesn't stick around very long. I mentioned instance roles before. Like wherever you can, IAM roles are great because AWS manages the credentials for you and their rotation and everything else. So instance roles for EC2, assigning roles to your ECS, EKS, Lambda, all of those kinds of things. Definitely make use of that where you can and use those roles to authenticate to things as well. Quite a few common DevOps tools and things will support IAM-based authentication. And so it's well worth doing that too. Again, fewer credentials for you to worry about managing. And lastly, where you have got credentials that you've got to manually manage, it's worth looking at things like, for instance, HashiCorp Vault or CyberArk or some of these other sort of privileged access management tools that will often auto-rotate the credentials after you've used them, just because it then means that you don't have these credentials sticking around for ages. 5 different engineers have had access to them in the last month. You don't know who's used them. It's worth looking at that, but that is lower down on the priority list than the other things, both because of the engineering effort required and because there's usually a significant cost associated with them in terms of actual raw money. Limiting blast radius. So this is something that you see AWS talk about an awful lot with AWS organizations and their multiple account structure, but have separate projects, separate workloads running in separate AWS accounts underneath your AWS organization. And on top of that, have separate AWS accounts for dev, test, production. Accounts don't cost you anything. And the more you have of them and the better segregated these things are at the account level, the lower risk there is presented by any given compromise. If I, as an attacker, break into one AWS account and the only thing running in it is the test workload for an application and we haven't got any production data and it's in its own account and there's no ways to jump into other accounts from there, then as an attacker, I'm essentially stuck. I can't get much further than that, right? AWS accounts are a significant security boundary or blocker to an attacker, so definitely worth doing that. Likewise, at the network level, avoid VPC peering if you don't really need it. Think about what network routes you're exposing between these different environments. And when it comes to things like CI/CD, if you've got a single CI/CD system that deploys everything to dev, test, production across all your different workloads, you've got a single point that an attacker can go after to compromise all of them at once. So there's a balance to be struck there between making life hard for yourself by running thousands of different platforms and sensibly segregating stuff out. But I think it's worth thinking about how you do that. And for instance, potentially running separate CI/CD pipelines for production versus dev and test. And when we talk about CI/CD, something that an ex-colleague of mine wrote up recently that really caught my eye is this idea of push-based versus pull-based CI/CD. So usually when we're talking about continuous delivery, deploying things into the cloud, what happens is you have a dev commit some stuff to a repo, the CI/CD system takes the things out of the repo, builds it, deploys it. In the case of Kubernetes, you're probably pushing an image up to a container registry and then telling Kubernetes to pull the new image down. So the problem there is that CI/CD pipeline has the rights to both push new content into the container registry and then force Kubernetes to apply it. So an attacker who compromises that then essentially has control over the Kubernetes cluster because he's got the rights to do both. So where we have pull-based CI/CD, we still tend to push things up into the container registry. There's not really a sensible alternative approach. But what we have is the Kubernetes cluster in this particular case, but you could do it with Lambda functions or a number of other things, actively pull from the repository into the cluster the new configurations. And that means the rights to deploy new things live within the Kubernetes cluster or within the AWS account rather than in the CI/CD pipeline. So you've got to breach that cluster or that account before you can, as an attacker, start manipulating it, as opposed to being able to pull the credentials out of the CI/CD pipeline. One good example of this is Atlantis, if you use Terraform. So Atlantis runs in an isolated fashion off on its own, basically pulls in Terraform from Git repositories that you tell it to monitor on a webhooks-based system. So you set up GitHub or GitLab to make a webhook to say, new merge request. Atlantis then runs a plan for you, you merge the request, Atlantis then applies it. But the credentials for doing the Terraform apply live inside Atlantis itself, which you can run inside your cloud account. And so therefore, the credentials to actually manage the environment never leave the environment, right? They stay within Atlantis. They're not in a CI/CD system somewhere else, which makes it harder for a dev to get in and get to them. Not impossible, but it is harder. Avoiding people in production. So this, again, carries on the previous theme of trying to keep people away from production secrets and production data where it's all possible. Human production access is something that should be a break glass thing that happens when all other steps have failed, right? So you want to design your systems to reduce or eliminate the need for humans to be logging into production and poking around. Generally, the way we see people do that works is really robust logging. available to the developers, both at the application and infrastructure level, and having a CI/CD system that allows developers to rapidly push fixes out. Charity Majors, who's the CEO, I think, for Honeycomb, one of the big observability platforms, has always said that if you have a CI/CD pipeline that takes longer than 15 minutes, it costs you a ton of effort, both when it comes to incidents and lost developer productivity. If you can deploy things under that magic 15-minute mark, you can then use your CI/CD to resolve production outages, at which point you don't need people logging in to fix things in production. Where you do have to have people logging in, use production access control. So have a way that means a developer has to request access and be granted that on a sort of a just-in-time basis for a period of time in order to get into production and do things. And ideally then monitor what it is they're doing while they're in there, both through CloudTrail and also ideally, bash history logs or whatever else from the system they're doing it from, so that you can monitor what they're up to and make sure that while they're in there, they don't do anything they're not supposed to, right? And that will both reduce your incidents from people making mistakes in production by manually logging in and poking around, and it also reduces your potential damage from insider threats, disgruntled employee or that sort of thing. When it comes to authentication, I think there's a few things to think about here that I typically like to talk through. First off is standalone SSO. This is probably my favorite model. But you also see people doing Active Directory federation, so using your Active Directory to log into your cloud. That's really common. And then the two other models for AWS, at least, are organization level sort of identity accounts full of IAM users, or IAM users created in the individual project accounts. Now, I said standalone SSO was my favorite. The reason for that is that most people's Active Directory configurations are less secure than they'd like to think. So if you get a compromise on premises, it often means you've then got a cloud compromise too. At least with a standalone SSO, an attacker's got to get a fresh set of credentials for it. For the IAM users, I don't like that approach for two reasons, really. One of which is it tends to get harder to manage because it's yet another system that you've got to log into and keep track of your joiners and leavers and things. And when it gets to per project, it means that the poor developers then have to maintain a ton of different credentials for different environments, and tracking who's supposed to have access versus who's actually got access becomes a real pain. So if you're designing this stuff from scratch, something like AWS SSO or Okta One Login Ping, there's a number of options there, is my first recommendation. A lot of businesses choose to go the Active Directory route because it works easiest with everything they've already got. Secrets management. This is the thing that I end up reporting on most on engagements, probably after misconfigured IAM policies and roles. This isn't something an attacker usually starts with, but it tends to be very useful once you've got an initial foothold. When you're looking at your cloud environments, think about like how secrets are being stored and managed and accessed. And by secrets, I mean TLS certificates, API keys, secret keys for encryption, anything like that. Think about where they're being stored, how they're being accessed, and also ideally have some monitoring as part of your CI/CD to scan new code that's being committed to make sure that people aren't committing secrets into your source code repos. Now, for AWS, your best options here are to make heavy use of Secrets Manager or Systems Manager Parameter Store. Up to you, really, which one you pick. From a pure security perspective in terms of what an attacker is likely to do, there's not really much of a difference, and they're about as easy to get to as each other. Or equally, if you're already using things like HashiCorp or Vault or any of these other secrets management systems, that's great, that's fine. But where you can, use IAM-backed authentication so that you can have your EC2 instances or your Lambda functions use their IAM roles to authenticate to Vault, rather than having to store Vault credentials with the applications themselves. And it's worth having a poke around your environments and seeing if you can find any secrets. The most common places we see them generally, EC2 user data, there's a 60-70% chance that if people are using EC2 user data, there's some credentials stored somewhere in there. Hard-coded in CloudFormation templates or Terraform is another really common one. Application source code occasionally. Sometimes the environment variables in Lambda, and sometimes people leave them lying around in S3 buckets. But what you should do instead, especially for instance for the EC2 user data, is you have your EC2 instance have an instance role that can access Secrets Manager for the secrets it needs. And then in that user data, you use the AWS CLI commands to pull in the secrets where you need them. It's a fairly easy pattern to implement, works much better, and stops security consultants like me coming along and finding all of your credentials lying around the second we start looking at your environments. Now, I promised a bit about scaling cloud security out across larger organizations, so I'm going to take a few minutes now just to talk through that, because I think there's a few things to learn here, even for smaller organizations, because most organizations want to grow, and you're likely to hit some of these problems or see some of these solutions as being useful later on, even if you don't see it now. So first up, centralizing management. So what I mean here is bring all of your cloud workloads under a centralized management system of some sort. If you're only using AWS, then having an AWS organization with all the accounts under it, having some sensible service control policy to apply the right kind of restrictions, and using things like organization-wide CloudTrail and guard duty will make your life easier, especially as you grow out. If you're a multi-cloud organization, then making sure that you have some kind of centralized process for managing all of your cloud workloads is definitely worth it. Exactly what that looks like varies enormously organization to organization, depending on culture and politics and a lot of other things. So I won't dive into that here, but it's worth thinking about that sooner rather than later if you are expecting to go multi-cloud. Generally speaking, if you're multi-cloud or you're expecting to go that way, provider agnostic tooling is a really good bet. So Terraform instead of CloudFormation, Cloud Custodian or Dome 9 or any of these cloud security posture management tools, rather than relying on AWS config. It just means you've only got one tool to worry about rather than two or three as you scale out. If you know you're going to stay AWS, CloudFormation is great, but if that's not likely to be the case, then Terraform might well be a better bet. And for each provider, having a security account that all of your logs get written out to, where the workloads themselves have write-only access, so they can record the logs, but they can't get back in and do anything to them afterwards, is a very good thing to do. Likewise, having an account that does all of your security monitoring, for instance, have that isolated off to the side with as few people access to it as possible, makes life a lot easier rather than trying to run all your security tooling in the same accounts as the workloads. Makes it easier to lock down and reduces the burden on the individual engineering teams because it's all centralized. Talked a little bit about logs just then. Other things to think about. Specific log sources that I always recommend everyone have are CloudTrail, which is a sort of a broader category of what I call control plane audit logs that log administrative activity in the cloud. Then you've got service-specific logs, S3 storage access logs, Lambda execution logs, KMS key access logs, these kinds of things. Those are the two main ones that I think are really important to have. And then VPC flow logs, having guard duty turned on is well worth it. These are other things to consider. But I think those two are the primary ones for reasons that we'll talk about now. CloudTrail, for those not familiar, it's the central log source for all of your actions taking place in AWS. Anytime you create a new EC2 instance, tear down a Lambda function, alter the permissions on an IAM user, anything like that, CloudTrail logs it with a few very small exceptions. If you're building out your security monitoring in the cloud, this is the step zero. You need this. This is the first thing to turn on. So get that done. Start building some monitoring around that, and then start building other things on top of it later, is my usual advice. When it comes to the service-specific data events or object level logging in S3, these kinds of things, I don't generally recommend turning them on all at once for everything, generally because they generate vast amounts of logs. And so what you'll find is that your log storage bill and log processing bill goes up quite a lot for comparatively little security benefit if you just turn it on everywhere. So what we recommend doing is looking at the key resources that you're going to need the logs for from a security monitoring perspective. Let's say you've got an S3 bucket full of like bank statements for your end users. Monitoring that's probably worth it. Equally, if you've got a bucket just serving up JavaScript and HTML files and things for your website, you probably don't care about read access to it because the intention is that everyone can read it so it can serve the website, right? So tune this on a per resource basis. You'll likely want some, but you definitely won't want all. And we talked about centralizing things as you scale so far, but actually there are a number of things that need to move in the opposite direction. And one of the things that a lot of businesses I work with really struggle with is this idea that the security team is essentially no longer the most important team when it comes to security in the cloud. They are important, but really the engineering teams, those building the workloads, are the subject matter experts in what they're building and are likely to have the closest or the greatest knowledge of the technologies they're using and how they're using it. So the important thing is to inject security knowledge into the engineering teams rather than have security sit up in their tower as they always have done and sort of dictate things down. And as an extension of that, one of the best things you can do when building a security team working in the cloud is hire ex-cloud engineers who are used to building and maintaining workloads. A, because it helps you build security automation, but B, because it means they're people who are used to dealing with this stuff, so can talk to engineers at their own levels. And actually, that's a really uncommon skill set right now. Ex-cloud engineers who want to do security. There's also a huge job market for it. So if you're interested in moving over, I'm sure there'll be plenty of people who'd love to have you. And most businesses will need to invest heavily in that because they're going to need it from a security perspective. You can't have attackers breaching all your stuff and losing your reputation with your clients as a result. But cloud security people are expensive. So yeah, there's a cost associated with that. And as an extension of that, central security teams pretty much never have the bandwidth, really. That's the core thing. A lot of our clients have security teams with a few cloud experts and 50, 100 workloads running in the cloud, with more being added all the time. And there's just no way that their experts can scale like that. So having a process whereby engineering teams can make requests of security in an efficient way, and you can work out quickly, it's a small change. Security probably don't care. This is a complete new system that we've never looked at. Security definitely does care. Let's come have a chat. And I always say to security teams when I'm helping them build these processes that the most important thing here is to have a process that works for the engineering teams that you can also live with. The priority is on making it as seamless as possible for engineering, because if you don't, then people just do their own thing. And security is slowly getting used to the idea, I think, in many organizations, that they are a support function that enables engineers, as opposed to being gatekeepers that block things from being released, as perhaps they have done historically. And it's a cultural shift that's happening, not as fast as I'd like, but it is happening in most places. And I'd be interested in hearing your thoughts on that in particular, but also on anything else I've had to say. After this, once we wrap up for questions. The last point here, when it comes to scale, is automation. One of my big things that I like to drive here is building out your CI/CD pipelines to automate analysis, building out tools to monitor what you're running in the cloud and automatically at least alert, but maybe actually just go in and fix common security problems like open S3 buckets, things like that. So there are a number of tools out there that will do this for you. For analysis in your CI/CD pipelines, you've got CloudFormation Guard, which is an open source thing AWS released, or Checkov from Bridgecrew is my other favorite. You just grab those off GitHub and run them as static analysis tools on your infrastructure as code. They'll catch an awful lot of things before it even gets deployed. You can then also use things like Cloud Custodian or a lot of these commercial cloud security posture management tools to monitor what's running in the cloud and step in and fix even where things are broken or need changing. The other thing that's often missed here, though, is the opportunity to use that to educate engineers and developers. So if you catch mistakes in CI/CD or in running in production, the best thing you can do is send a notification back to your engineers that says, hey, we've noticed you've made this security mistake. Our policy internally is X, Y, and Z. Here's how you should do it. Here's a link out to the documentation that tells you how to do it right. Please go have a look. And the shorter you can get the cycle time between the engineer making the changes and getting it wrong and them having that information put in front of them, the greater the chance of them remembering that next time round. It's a psychological thing, basically. The closer you are to short-term memory when people receive information about something they've done, the more likely they are to retain it. So that's a really powerful process that I've seen used really well at a couple of our bigger clients to educate their engineers. Worth thinking about. It's not very common at the moment, but I hope it becomes more so. So to wrap up, I think we're about on time. I might be running a minute or two late. The security of your cloud isn't just about the things you're running in AWS. There's a bunch of other stuff to consider as well. But the things that most commonly get people breach are getting the basics wrong. It's the public S3 bucket, it's the open Elasticsearch databases, credentials being pushed to GitHub. We're still at a stage where a lot of organizations don't have a good grip on those basics, and so they're getting breached that way. Once you've got those basics down, the next big things to focus on are your identity controls, your secrets management, segregating your environments out properly, and looking at how you're doing CI/CD, and both whether you can get some security tooling in there to improve the quality of your infrastructure as code, catch security bugs there, but also from a hardening perspective, how easy would it be for an attacker to get in and manipulate your CI/CD pipelines? And if they did, what's the potential damage? And then the way you scale security really is by decentralizing things, pushing stuff out to the engineering teams where possible, giving them the knowledge, the skills, and the resources to go away and do good security rather than relying on your central security team to do it. And then leveraging automation wherever possible to go in and help engineers do that. And so lastly, just before we do wrap up, I mentioned Leonidas at the beginning. Essentially, it's a framework for simulating attacks in AWS. You write some fairly short YAML-based definitions as to what an attack is, usually involving a couple of lines of Python to call the right Boto3 API calls. And then we have a CI/CD pipeline that's part of the project that you deploy, that then builds out a Lambda function and exposes a web API. So you can script up like start to finish entire attacks, with a few curl calls basically. At the moment, it's AWS only. We've got some plans for GCP and Azure as well, if that's your bag too. And we're currently at about sort of 45 or 50 use cases, individual attack components that you can use to test out some of these things and see whether you'd spot someone doing it, whether it actually works in your environment, these kinds of things. So worth a look. And if you do try it, let me know. And with that, I think I'm done. Have we got many questions? Fantastic. So I can see we've got a few here.
Yeah, we are having few questions. Let's go with Bood00. First question, would it be a best practice to lock down IAM policies associated to an EC2 instance using conditions such as source IP?
So that's an interesting one. Source IP I generally don't recommend, purely because people change the IP ranges associated with their cloud on a reasonably regular basis in my experience, or at least you can't guarantee when it's going to change. So I've seen people do source VPC and then use infrastructure as code to tie that as a variable to the ID for the current VPC that the resource is deployed in. But the thing to go read on that is if you look at Netflix's security blog, and basically do a Google search for Netflix detecting credential compromise in AWS and preventing credential compromise in AWS. They've got 2 blog posts that were written by a fantastic security engineer on how Netflix do it, and they've got some great ideas. So I would just go read those and take the advice out of that.
Perfect. Another question from Elena. She said you mentioned Shodan and it was possible to search for sensitive data exposure. Is there a way in which you can scan your app to make sure no sensitive data is exposed? I think someone answered, but let's take your answer also.
Yeah, so Shodan's an interesting one. The way you use Shodan is generally to look for classes of things that are exposed on the internet rather than things that are tied into a specific company or workload or what have you. You certainly can use it to look for ports that are open on your IP ranges or for specific IPs you know are associated with your AWS accounts. Equally, keyword searches by common terms associated with your organization, like with your organization, like the organization name or division names, things like that, will often find things. So I would go have a play around with Shodan. The search interface is reasonably intuitive, and they've got quite a good guide on the different filters and things you can use. And what I do with that then is have a look for key services exposed that shouldn't be. Elasticsearch is one of the big ones right now, but equally, if you're running Mongo, have a look at the Mongo ports as well, things like that.
Okay, thanks. We're having another question from Sergio, and I think one of the last questions. If there is any question from the crowd here, please shoot it before we go to the quiz. So this question is about the authentication on AWS from on-premise for scripts and other coded access. What are the best practices when you're hybrid?
Sure. So, and this is where most people end up falling back on IAM users. Unfortunately, there's not a good way at present to do this out of the box with AWS that I'm aware of. I'm happy to be corrected. So what I commonly see people doing is using things like CyberArk or HashiCorp or Vault or these other privileged access management tools to provide that bridge. So they'll store privileged credentials for themselves or for that app to use to generate or create the necessary credentials for on-premises usage. If you're not wanting to bother with all of that, because it usually is a fair bit of work, IAM users with access keys that get rotated occasionally, don't have to do it that often, but at least once a year. AWS Vault is a great tool for encrypting those keys at rest when they're on your laptop, using like the Mac OS keychain or the Windows secret store, instead of just leaving them in clear text on your disk. So I've got AWS Vault set up personally. I use that all the time. So that is your best option for where humans are doing things, I think. Hopefully that answers the question.
Yeah, I think it answered very good. And you're having Gregory saying thanks for mentioning AWS Vault.
It's a great tool. I love it.
Yeah. And we have a question from Savata, but I think you answered it during your talk. He was saying, ideally, where do you store the password and that you want to share with your ops team? And I think you talked about Secret Manager.
Yeah, so I mean, you can use Secrets Manager and things like that, or have LastPass or any other shared password manager. I think what I would say is I would look to reduce the amount of passwords you have to share as much as you can. And the easiest ways to do that are usually having IAM roles you can grant to the ops team as they come in through your single sign-on. Grant access that way rather than having access keys and things where at all possible. And as I say, many DevOps tools will let you authenticate with AWS IAM backed authentication. So you can use IAM roles to get into these tools instead of having to just have passwords lying around.
Yeah, definitely. Yeah. Okay. Any other question, guys? I think there is no other question for now. Let's just maybe a last one. No? Okay. So let's jump to the end. So Nick, thanks a lot for your talk. It was very interesting. I think people.
Thank you for having me.
Yeah, it's a pleasure. Very interesting, and this security topics is top topic. So yeah, come when you want. Again, if you want.
Fantastic.